My name's Andre Andriola,
My name's Pat Gervin.
I'm Charlie Alexander.
and we're Physics Systems Engineering Team 12, Design Phase 2. So here we're going to talk about project management, intellectual property, concept generation and selection, failure modes and analysis, as well as economic analysis. So to start us off, we have a design structure matrix, and as you can see, we have 15 tasks which are finished with a final presentation on everything we've done throughout this project. And we begin with customer needs, and then target specifications, and then the intellectual properties, and then we begin into coupled tasks 4 through 9, and then the rest are repeated until we finish up this project. So to go more in depth, we decided to divide up the concept generation process into 4 separate things, which include the concept generation, the concept screening, the concept scoring, and concept selection. And then we originally planned to have CAD models and concept testing in phase 2, but for unforeseen circumstances, they had to be moved to phase 3 to help with time. And then, as I mentioned earlier, tasks 4 through 9 were a couple tasks which included all the concept generation and the economic analysis, and then CAD models. And then up through now, tasks 2 through 8 have been completed.
So a big part of this project is going through intellectual property. We looked at patents to be sure that we're not repeating someone else's design, we're not stealing someone else's experiment. If we go into the patent search and we find that someone's done a similar project, it may have limitations on our design. Luckily, we went through about 6 different designs on patents, and we found there were no limitations on our design. But the good thing is, by reading these, we can get ideas on what we can implement into our BRG or into future iterations. So for example, patent 6,382,982 was an educational tool. So this tool was basically made for optical and electrical components to teach kids about light. And so it had all these different components that you can move around and change the relay, change the power rail, and get different outputs out of it. So while this doesn't directly involve the BRG, what we could do is follow a similar strategy where we have our wheel and our ramp, and we can move them around and let the student or the teacher make different designs out of the parts we give them. And then after we went through the patents, we went through concept generation and selection. So first, we all got together and we started brainstorming what can we actually put together. Came up with tons of ideas. We mainly got it down to 4 different ideas. And then we went through the gallery method where we showed our ideas to other teams that we were involved with, and they gave us feedback. This is not a good idea, maybe you should try this. And then we took it, went back into team brainstorming, and made it an iterative process. So then we went through concept screening to make sure none of the ideas we came up with were too outrageous, not possible for any reason. Could be economic reasons, could be fundamental, just doesn't work. None of our designs failed concept screening, so we went right ahead and moved into concept scoring, which was for concept selection. So by ranking different criteria that we're going to select our part by, we could score them and see where they all fit and rank our different designs, our top 4. We ended up deciding to use an Arduino and servo motor to turn a wheel. We did this because we thought that it had the best teaching ability, and that was weighted the heaviest on our concept scoring of 35%. So with this idea, we can teach kids about linear motion, angular motion by the wheel, angular acceleration. You could also do energy with kinetic energy and potential energy as the wheel takes the ball up to a higher height. So that gave it a pretty huge score with a 5 out of 5 on the teaching ability. And it also, although it's a little harder to use, most of its design is pretty good.
Okay, so in order to develop the best product that we can for our customers, we need to determine what parts have the highest potential for failure. So we did failure modes and analysis to determine this. So we have our components of our BRG, which include a wheel, the servo motor, the ramp, the Arduino, and the rail or the guide. So what we came up with was that the best way to do this is to increase the strength of the material to prevent breakage. It's not as common, or it's not as easy to get done with the Arduino or the servo motor because those are not necessarily produced or made by the company, so we have to buy those from somewhere else. So unless we can contact the company to make them stronger, we can't really do anything about that. But the wheel and the ramp and the rails, we can increase the strength or change our material to make it stronger, but this also might have an effect on the cost as well, so that's something to consider. On top of that, we can sell individual parts. We can, instead of having them all sold at once, we can include like extended packages that can make it easier for the customers to buy more supplies if they need to. And like I said, they can add extra parts with the purchase, so instead of having separate kits, we can just have it all in one kit with extra parts. So for our economic analysis, we decided that the loan would be good for, or we would make a loan of $25,000 at 10%. And the purpose of this would be 15,000 of it would go to producing 180 units, and 10,000 of it would go to acquiring the necessary parts. The first year we would produce 350 units, $150 to sell at a $55 production rate. So for the revenue for the first year, if we sold 350 units like we planned, we'd have 52,500 revenue, and then the profit would be 33,250, and then our payment on the loan over 1 year would be $7,886 a quarter, and with a future value being $36,000 at the end of the first year. So for our project's future, we are going to finish design phase 3, which will include CAD models, 3D models of what we intend to have our product look like, so that way we can have a better understanding of how we want to build it. And using the CAD models, we can also determine what materials we want to use, because the software allows us to use different materials that we can construct the BRG with, so that way we can determine different stresses and how the ping pong ball will affect the design and how it will affect the course. So, and then we also have product architecture and industrial design. So same thing, we need to figure out how we're going to get the molding done, how we're going to assemble the parts in real time as opposed to virtually. So how we're going to manufacture the parts, what materials we're going to use, if we want to use like the same company or if we're going to outsource it to different companies in order to get it done in the most economically efficient way as possible. And then manufacturing time and cost, the same thing, to decide how we want to get it manufactured, so that way we can have the best product or highest quality product for the lowest quality price, so we can maximize profit for our loan and for our company. And if you have any further questions, please feel free to contact Team 12. Thank you.
Thank you.